Hi everyone, welcome back. Last time we set up these constructors to build new characters in our game. So we can enter the parameters that we need: name, level, experience, initial stats, and our maximum stats, or at least the base stats of our highest level. And we have another stat struct inside our character struct that handles these stats. So one thing I wanted to do back in our character constructor, I was going to take out this XP equals XP. Originally I showed it off just as an example of how the character struct can have its own parameters exclusive to it apart from the inheriting constructor. But we don't actually need to pass in experience when we build our characters. They'll always start with 0. So I'm just going to have XP equals 0 here. I'm going to take out the parameter. And then we need to do it in our character as well. So while this character struct being held in a global array represents our character stats, all their information, the physical representation of our player out in the world was this OPlayer object. I mentioned in the last video we want to have the player communicate with the struct in some way. So in our player, we're going to create a variable called unit, and then we'll have unit equal character 0. So now our player object holds a reference to what unit among our player party it's supposed to represent. And then we need it to go the other way too. Our struct is going to need a reference to whatever object it's connected to. So I'm going to add another variable called actor inside the character struct. I'm going to set it to no one. Then back in the player object's create event, we'll say unit.actor equal ID. So when the player object is created, it sets the character 0, the first new character we made, who I named Mars. It sets his actor to be the ID of the player object. Okay, so now we got to start thinking of more methods we want to have inside the character struct. So I want to create a method for handling damage. It'll reduce the stat for our HP, and then a damage number will pop up over the player object, over whatever actor is connected to the struct. And we want to make it a method because we want to keep our code dry, which means don't repeat yourself. So for example, back in the enter event for my game manager, what if I wanted to damage the player inside of here? When I press enter, the player takes damage. So I could do character 0.stats.hp minus equal whatever damage I want. Let's say 10. Okay, so sure, that works. That subtracts damage from the current HP. But what if that damage is more than the current HP? Now the player has negative HP. Vice versa, what if you were to heal the player and you healed them for more than their max HP? So for that you would have to handle it like this. Now you would have to use this min function, or sorry, you would have to use this max function and be either 0 or you'd have to type all that in again, character.0.stats.hp minus damage. So now it would get the highest one, so if it goes below 0, it would set it to 0. Oh, but now what if the player dies? So now we have to think of a whole logic to handle what happens if the player dies. And then we'd have to type all that up every single time we want the player to take damage anywhere. rather it be from something in the world or from an enemy in battle. So to keep our code dry, we'll create a damage method inside the character struct that will handle all of that for us. So remember, when we're creating methods inside of structs, we want them to be static, so we're not making new functions every time a new struct is created. I'm going to call this static and just call it damage. And for our argument, we want the damage. And here we can say just like that. We can do a similar thing for healing. I'll put in an argument called HP restored, and then our HP will equal the minimum between either our max or their current HP plus the HP restored. So if I wanted to test this out, we could put that back in the enter event, or just create an event like in our game manager where you press a button, we can damage the player. But I thought it would be more fun if we took this opportunity to put in damage floors, damage tiles, like a pool of poison. You know, like in Dragon Quest games, you get that purple poison water, you step on it, you take some damage as you walk, or lava or whatever. So in our sprites, in the tiles folder, I'm going to create a new sprite called S damage tiles. It's going to be 32 by 32. So we're making it a tile set, so the top left has to be blank. So we'll put our poison tile in the next row. We'll make it a transparent purple. Okay, now I'm going to create a tile set and have it set the sprite to it. I'll call it T damage. And not every room is going to have a damage floor. Not every room will have a poison swamp or lava. So I don't think we need to put that in our parent event. And we can just add a new layer to whatever room has damage tiles. I would put it in between collision and tiles lower. I'm gonna name it tiles damage. I think the one disadvantage to not having it in the parent is you have to remember to give it the same name every time you create it. So if you think that's going to be a problem, go ahead and put it in the parent, but I'm just going to put it in rooms that will actually use it. And if you are putting it in the parent, you don't have to worry about this, but for my purposes, I'm going to have to check that it actually exists. And I think allies will be able to take damage from these floor tiles as well. So I want to put this in the parent player and not the object player. So in the create event for the parent player, we're going to check if if the tile layer exists. So if layer tile map exists, and it wants the layer ID, so layer get ID. it wants the tile map element ID here. Tile map get ID. And then you set the same thing, you just copy this and put that in there. It's kind of redundant, but that's how it works. And then I'm going to say an instance variable called damage floor will hold the reference to that, so it'll hold pretty much all of this. Just like how we did the collision map. Oops, yet another parentheses, my bad. And I'm actually going to first define the damage floor up here to -1, and then we'll check it and set it. And so this way we always have the damage floor variable to work with even if it doesn't exist. And okay, I just realized I needed to add another parentheses up here. Okay, so my whole if statement's in a parentheses, then the tile map exists arguments are parentheses, then yeah, we have functions inside functions. I got a little messed up there. But okay, so that's good. Now inside of player functions, well first, let's go back to our player object. And I'm going to create an alarm. And I'm not going to put any code inside of the alarm. I'm just going to, well, it needs to exist, so you know, it doesn't actually need code inside it, but I'm going to give it a description. It's called damage tile tick. Now in our script for player functions, I'm going to create a new function called damage tile check. It doesn't need any arguments. And back in our states, the state script and the movement state, I'll call it here. And we'll use that damage floor variable to decide if we even should be checking for damage tiles. So if damage floor does not equal -1, then we'll call that function. Okay, now let's actually write code for the function. So we'll say if tile map get at pixel. If you remember these from our collision video, damage floor and just our X and Y, and then we want to check that that alarm is off. So this way we're not taking damage every single step, every single frame that we're standing on poison. We only want to take damage at intervals. I'm thinking we'll take damage every second that we're on poison. And inside of here we can call that method we made for taking damage. So normally you would say character 0 dot damage, but remember this damage tile check function is being called in the movement state, and that state is being called from the object player, the O player, and O player already holds a reference to the struct, the character struct that it's tied to. And this will be helpful for when we set different characters to be the main character. But unit represents the character struct that O player is representing, so we'll say unit.damage, and then however much damage you want the character to take from poison. I'll just do 1 for now. And then we need to set that alarm to something. I'm going to set it to frame rate, which is a second, 60 frames, so that way we're only taking damage every 60 frames and not every frame. So let's run the game and make sure that works. Alright, I have our stuff up here. I added a draw event to our game manager that can just draw our current HP and our max HP. Oh, well, we have to actually add poison tiles to the room. I forgot that. Okay, first of all, though, here's that draw event for the game manager. In the last episode, we just had it draw the max HP. I added more to it so we can get the current and max. And that's just for testing. Obviously, the final game won't have that. Okay, so back in test room A, on our tiles damage, we'll load in the T damage. Now we can paint a poison pool. Okay, so let's run the game now. Alright, and you can see every second I stand in the poison, my current HP is ticking down. So let's get out of there. Now normally when you take damage in an RPG, you have damage numbers pop up. So how about we do that and get a feel for how it looks with the poison. So I'm going to create a new object. We'll put it in a folder called Interface, I think. That'll hold various UI objects. I'll call this O points. Of course, it won't always be damage numbers. Sometimes it will be healing numbers as well, so I think points is a better name for it. And I'm not going to set it to anything yet. I'm not going to put any code in there. I'm going to create a function in our helper scripts called drawPoints. For arguments, we'll do value, color, and actor, or unit. Okay, so the value is going to be how much the damage or how much the healing is, which number should pop up. The color will be for different types. Damage will be red, healing will be green, and the unit will be which character this number is supposed to be drawn on top of. So I'm going to say with instance create layer, and even though we're going to have it drawn on top of the unit, it doesn't actually need to be on top right now. So I'm just going to set X and Y to 0, and we're going to set its X and Y later. And now we want the layer to be UI. Our game manager creates that at the start of every room. And O points. That was in our room transition video. We made the UI layer. Okay. Then we can pass these values in. And this will happen when you use the when you use with for the instance creation. Whatever you type in here will be added to the end of its create event. And so we don't actually need to create these instance variables inside of the O points. They'll be created here. Now I want the damage numbers to start from the top of the player. They're going to be very simple. I'm just going to have them float up, but I want them to start at the top of a character. So I'm going to say y equals unit.bboxBottom minus sprite get height unit.spriteIndex. So that should work. Okay, back in O points, I'll create a step event and a draw event. So first of all, I want to create an instance variable called yTarget. Well, it can be a local variable actually. And I'm also going to set it to unit.bboxBottom minus their sprite height. And then minus another 16. So that's where the target will be. So we'll start at the top of their head and then move to 16 pixels above their head. I wanted to put this in the step event because we're going to be moving through the poison. So if we move up or down, I like to keep it somewhat relevant to where the player actually is on the field. If you're just doing damage numbers in battle, this obviously won't matter. And then we'll use linear interpolation to get our y value change to have the number float upward, so it's not floating up at a constant pace. It'll kind of like start faster when it starts and then ease into the y target. So we'll say y equals lerp y target, and then some kind of speed variable. I'll just do 0.1. Okay, now I am going to add a create event. Like I said, we don't actually need to define unit or value or color in it. Those will be defined when we create this. But I am going to set an alarm. So this will be how long the number actually exists before it fades away. And I'm just going to have the number exist for half a second, so frame rate divided by 2. And then I don't want the number to instantly pop out of existence. I want it to have a fade out. So I'm going to create another variable called fade away, and I'll set it to false. In the step event, if fade away is true, if it equals true, then, well, we should have another variable called %. That'll be set to 1. Then I'm going to have % equals max, 0% minus, and then you can enter however fast you want it to go away. I'm going to do 0.1. So that'll make the number exist for an entirety of 40 frames, and it will be fading away on the last 10 frames. And then when the % is 0, we'll destroy the object. So in the alarm, once those 30 frames have passed, we'll say fade away equals true. Okay, so now we have to draw our number. So normally we would do draw text, and we can say the unit's x and then ry. So I'm just setting the x to the unit's x here, since like I said, I like it to move with the player if they walk around, since the number is just floating up and down and never interacts with the horizontal axis. It can just stick to the unit, while for the y we need to actually change it. So I'll just use the object's own y, and then we can use that numerical value as a string, like that. Okay, but first of all, if you saw where I had our HP drawn at the top of the screen, the current font is set to some big chunky non-pixel numbers. So how about we create a new font? I'll call it font main because this is going to be the main font we use for the entire game. And I'm going to set it to a font called Resource. This is a 100% free pixel font I found. I'll have a download link to it in the description of the video. And the size should be 12. Now in our game manager, where I had this section for display and UI settings, I'm going to set the font here. And now anytime we draw text, it should default to font main. Unless we change it somewhere, then we'll need to remember to change it back. But for now I'm planning to use this just for the whole project. Okay, so that's the right font we want. What if we want our text to have a shadow? We could copy this and move it up here to a line below it so it's drawn behind the main font, and just set the color to black. Oh, we gotta change the color too, so how do we do that? Well, there's this draw text color, but if you look at the parameters, what do they want? Okay, X, Y, and string, like we already have. Then color 1, color 2, color 3, color 4. That's because you can have a color gradient going through your text, which is neat, but we just want one color right now, so isn't that kind of obnoxious if we have to type in 4 colors every time we want to have a text of a different color? Like, for right now we would have to do, our XY string, then C red, comma, C red, comma, C red, and then for that shadow we would have to do C black, comma, C black, comma, C black. So how about we don't do that every time we draw text? Instead, let's create a custom draw text function. In our helper scripts, let's create a new script called custom draw functions. And I'm just going to call this function draw text. So this works because I'm naming my variables and functions differently. Like, I can use that Pascal case, so it is my own. Like, the built-in one is one snake case. If you're using snake case for all your naming, I mean, obviously you'll want to name this something else because you'll just be calling the built-in draw text. So maybe call it draw text custom, or my draw text, or draw text advance, whatever you want. For me, I'm using Pascal case. It won't matter. It won't. GameMaker will understand it's a different function because it doesn't have the underscore. It has the capital letters. So for me, it's fine. Okay, so for parameters, we can have the normal X, Y string, and then we'll have our color. We only need to set the color once. Okay, and then I want to tell it if I want a shadow, and then I can tell it if I want it to be what I want the alpha, the transparency, to be. Except I may not want a shadow for every text, and I certainly won't want to change the transparency for every time I draw text. So isn't that creating the same problem I had with the draw text color function, where there's just more parameters than I really need, and it's obnoxious to type them all in? We can actually make arguments optional. So delete all parameters from here, and instead our arguments will be passed in as an array when we do this. And then we can create our local variables here and just set them to which element of the argument array we want. So x was the first one, then I'll create the rest. Okay, but then like I said, I wanted them to be optional, the last three to be optional. So, could do it like this. We could define the local variable and then say if we have that many arguments, if our argument count is greater than 3, so color would be the fourth argument. That doesn't match up with the arrays because those are 0 based. So the first argument is argument 0, second is argument 1. So color is argument 3, but it's the fourth argument, so we'll see if argument count is greater than 3, then color could be whatever the fourth argument is, argument 3, else we can set a default. Well, that's a lot of code to type just to check one variable based on whether one condition is true or false. There's actually a shorthand for this. So anytime you just want to set one variable based on whether another condition is true or false, instead of using an if-else statement like this, you could write it like this. In parentheses, first put your condition. So in our case it was if the argument count is greater than 3, and then you want a question mark, and then you set the true value. So if it was true, we did argument 3, and then the colon will separate the true result from the false result. So your true result, what color will be if it's true, then colon, and then what color will equal if it's false. Alright, and that's how we can set up our optional parameters. Shadow will be a Boolean. So it'll be true, or you can be false. And if you don't type anything in, it'll be false by default. And our alpha will be 1 by default. It'll be fully opaque. You may notice one problem with this. When we call the function, we no longer get that auto fill-in of what the parameters is. The help info at the bottom of the screen doesn't tell us. There's a way around that too. So above your function, do 3 slashes, 3 forward slashes, like you're writing a comment, then 1 additional forward slash, then use the @ sign, do @function, and the name of your function, then 3 forward slashes, param, and then you can enter the parameters. So param 0, the first parameter is x, and you can enter them like this. Now that should show them when you type in draw text. The help info should show you what the parameters are. Sometimes it takes a second to load. Okay, there you go. So we can see it shows us all the parameters we need. Another cool thing you can do with this is if you type in a colon, then you could write a description for each parameter. This is super helpful to remember the arguments of your own functions, or if you're building a game as part of a team, so other people can better understand what your functions do and what they need for those parameters. I just realized I forgot my shadow. Now we can type in the code here for actually drawing the text. So first, what if it has a shadow? So you can say if shadow, if it's true, draw text color, our x, then our y plus 1, the string. I'm going to make sure I format it as a string in case we entered a number, and then I never have to do that when we actually use this draw text function. Then we'll need to fill all 4 color fields and our alpha. And then just draw the text normally. So again, draw text color, our x, y, and string formatted as a string, our color entered 4 times, and then we never have to enter a color 4 times again, and the alpha. Back in our points object, we can use the newly created function. Oh, another thing you might want to do back in draw points, nope, back in custom draw functions, you can put an asterisk at the end of these just to remind yourself that these are optional fields. So we'll set the color to our color. We are going to use all fields for this. So the color value passed in through the drawPoints function, it will have a shadow, so true, and our alpha will be that percent variable we made. So when it fades away, our alpha value will go down to 0. So let's go back to the character class, and inside the damage method, we can tell it to draw the points here. For the value, we'll do whatever damage is passed in through the method's own argument. Damage colors will be red, and then the unit, we want our actor that the character struct is holding. So this way the number is drawn on top of O player. Or if it's one of our allies, then the actor will be an ally object that we've yet to create. And we can do the same with the heal. We'll make these lime a nice bright green. Otherwise it can be the same. Okay, so let's make sure I didn't forget anything and that this all works. Let's down to the poison swamp. And we can see damage numbers coming off our character. Now, what if you wanted the damage taken to be a percent of your max HP instead of a flat value? So back in player functions, we could handle all that here. We could create another local variable called damage, find the units, stats, HP max, and then, you know, whatever percent we want. If we wanted 25%. However, how about we just create a method that handles that for us? So back in character, the character constructor, let's create a new static method called damage percent. I'm calling our argument percent of max HP. So you can enter, in this argument, you'll enter whatever percentage you want, 25, 50, and then here we can say, we'll create a new local variable called damage, and it will be our max HP times the percent, and then divided by 100. So if you pass in 25, then it'll be turned into 0.25 and multiplied by max HP. In this case we have 20 HP, so that would return 5. And then we can call the damage method from here with the local variable we made. So instead of 1, we can say, what if we wanted 10%? So we have 20, so that should be 2 per tick. There we go. It's getting 10% of our max HP. So here's something fun we can do. What if we have different types of damage tiles that can do different amounts of damage? What if we had a poison floor, but we also had a lava floor? So let's create let's go back to our damage tile sprite, and I'm going to create a transparent orange tile. It'll be the next tile, so this one here. Remember, this one needs to stay blank. And to make these easier to tell, let's write on them. I'm just gonna put a P on this guy. And then we'll put an L on the lava. So back in player functions, where we did that damage tile check. So remember when we did this whole thing in the collision video, where we got the result of tile map get at pixel and then ANDed it by the tile index mask, and I explained how that was all used with the bitwise operators. This is the bitwise AND, where it's just 1 ampersand, and I explained all that ones and zeros for these. But the gist of it was, when you AND the results of tile map get at pixel with this constant, this built-in constant, you return which tile in your tile set you're getting. So for our collision tiles, 0 was that top left blank space, and 1 was the red collision tile. So we can use the same method, the same idea, to get if we're on the poison or the lava. So the top left is 0, that's blank, we don't want that. So the next one over is poison, that's 1. And then 2 would be the start of the second row, so that'll be the lava. Let's create a local variable called tile, and we'll put the tile map get at pixel inside of that. And then we can just exchange that for the local. So copy paste that over here. And I'm going to create another local variable called damage. Then inside of here, so if there is that tile map get at pixel and the alarm is ready for us to actually take a tick of damage, we'll say if tile and tile index mask equals 1, that's the poison. So damage will be whatever we want poison damage to be. I'll keep it at 10%. Else, if tile and tile index mask is 2, that's the lava. So we can set what we want the lava damage to be. I'll make it 25%. And then we can just pass in the local damage variable here. Back in room A, let's make a lava pool. On our tiles damage, take the orange one and color some space up here, or anywhere you want there to be some lava. Alright, let's run the game and see how that looks. We'll go through the poison. You can see we take 10%. and then go through the lava, and now we're taking 25%. Alright, so then what do we do when our player actually dies? So our HP drops to 0, but we're still alive, we're still taking down damage. So back in our character struct, let's create a new function called die. And we want it to be called from the damage function, so it'll need to be above it. It'll need to be created first before damage can use it. So static die. It doesn't need any arguments, and we're just going to have it reset the game. If I remember what the function for that is. There we go. Okay. So, inside of our damage method, we'll say if stats.hp equals 0, die. Okay, let's take some damage. The lava will kill us quicker. Alright, there we go, we restarted the game. Our HP is back at full, and we can go take damage and die again. Alright, so I think we'll end there. I hope that was helpful. And next time we're going to work on building our party, creating new party members, having them caterpillar behind us on the field, and having their own structs. So thank you for watching, bye!